number 60, I'm sorry, number 68. This says to calculate the pH from each of the hydronium ion concentrations determined in problem 66. So it's kind of like we got to do 66 anyway, but whatever. I'll just underline this one. So to get the pH from the hydronium ion concentrations that we should have calculated, we're going to need these two equations. First of all, we need to calculate the hydronium ion concentration given the hydroxide ion concentrations in the problem. So here's the equation we use. And then once we have the hydronium ion concentration, we plug it into the pH equation to get the pH. So first, to get the hydronium ion concentration, we solve for it. It'll be 1 times 10 to the minus 14 over the hydroxide concentration. I'm sorry, over the hydroxide concentration. So 1 times 10 to the minus 14 over 10 to the minus 12. This is simple to calculate. You shouldn't need a calculator. 10 to the minus 14 divided by 10 to the minus 12. It's going to be negative 14 minus negative 12 is negative 2. So the answer is 1 times 10 to the minus 2 molarity. That's the proton concentration right here. And plugging that into the pH equation, that gives you 2.00. Doing this for the rest of them, B, C, and D, is a similar process. So you're just substituting the hydroxide concentration down here for B, C, and D, and that part calculates the corresponding proton concentrations here, here, and here. And then plugging those proton concentrations into the pH equation gets you the pH. So it's going to be 4.70 for B, 10.78 for C, and then finally 3.95 for D.